For example, we still don't know how gravity works. We all know it exists. We're quite sure if we go off the roof of this building, I don't know how many floors it has, 10 or 11 floors, and step off the edge, you're going to fall down and hurt yourself pretty badly. And we know how long it will take and how fast we'll be going when we hit the ground. Einstein's relativity revised Newton's theory of gravity with better predictions. But it still has to include explaining why stepping off the roof of this building makes you go splat when you hit the ground. Even though we sort of modified the theory somewhat, it still has to account for pre-existing observations. And we don't know if Einstein's theory is true or not. There's some controversy in the physics community about the whole issue of dark matter and dark energy. Maybe our definition of gravity is not quite right, which is what's accounting for something like 96% of the universe which is missing. So that's a big part of the universe. Maybe it's our definition of gravity doesn't quite work when we look at interstellar distances, when you look between galaxies a million light years away. Maybe it does. Maybe there is 96% of the universe that's missing that we haven't observed yet. Anyway, so whatever is done so if relativity has to be changed, it still has to account for the observations we've already made. Your GPS, which most people don't realize, is affected by relativity. And if we change the definition of relativity, it still has to account for the fact your GPS knows where you are pretty accurately. Now, how does this all relate to, remember I was talking about research in the computer science world. So first, before we get to that, talk about homeopathy as a simple example of a pseudoscience. It was conceived by Dr. Samuel Hahnemann in 1810. It's based on the law of similars, like cures like. Any material that causes a reaction can be used if sufficiently dilute to eliminate that reaction. So if pepper makes you sneeze, then if you're sneezing because of some allergy, a sufficiently dilute solution of pepper can cure that allergy. That's the theory. Don't ask me for an explanation of it. That's the so-called theory. But by dilute, we mean really, really, really dilute. So 1x dilution means 1 in 10, 10%. A 2x dilution means you repeat that 1 in 10 one more time. So you get 1 in 100. 20x dilution means repeat that 20 times, or 1 in 10 to the 20th. But if you remember Avogadro's number back in high school chemistry, there's only 6 times 10 to the 23rd molecules per mole. So for water, it's about 18 grams of water. There's 6 times 10 to the 23rd molecules. So at dilutions of 30x, there's about a 1 chance out of about 1 million that even 1 molecule of the substance is present in a cup of the solution. So in a cup of water at a 30x solution, you may have 1 molecule. There's 1 in 1 million chance. But 1 in 30x is not much. Most homeopathic solutions are at least 1C, which is 100x. Or 1 in 10 to the 100th. That's a big number. It's estimated that the number of particles in the universe is only 10 to the 84 or 10 to the 85. So this, when you start counting out 10 to the 100, you get pretty big quickly. So homeopathy is big business today. Billions of dollars annually in the USA. It's used worldwide. It's just not a US phenomenon. In fact, if anything, I think it's bigger in Europe. So how do you identify pseudoscience? So here is a set of criteria. You can talk about use of vague, exaggerated, or untestable claims, over-reliance on confirmation rather than refutation, lack of openness to testing by other experts, absence of progress, personalization of issues, proof by authority, and lack of scientific method. So when we look at homeopathy, dilutions of 1C are non-measurable. We can measure 1 part in a million, 1 part in a billion, I think even 1 part in a trillion. But a trillion is only 10 to the 12th. We're talking about 10 to the 100th. So we have no way of even measuring anything at those dilutions. The higher the dilution, the better the effect. There's no way to test any of those. There's no rational underlying theory. And only the proponents can see the effect. There's over-reliance on confirmation rather than refutation. So you have lots of testimonials, no blind studies on the effects. Lack of openness to testing by other experts. An interesting thing about homeopathy is that the FDA was prevented by law from studying its effectiveness when the FDA was created, I think in 1938 or somewhere around then. And what's interesting, if you go to various homeopathic websites or products they sell, you'll often see a statement that says approved by the FDA. And I'm not sure what I'd call that outright lying or weasel wording, because with the FDA, all that homeopathic, in fact, what I've seen is where they say that these, just like pharmaceuticals, are regulated by the FDA. Well, that's patently false, because what the FDA what they only have to show with the homeopathic medicines is that they're not harmful, not that they do anything.
Which they can't be.
Well, that's another thing. They're just sugar pills. So since they're just sugar pills, of course, they're not harmful. But they don't have to show that they work. Where pharmaceuticals, there's a whole process where a drug company has to show that they're effective at whatever the company claims that they're doing. And there's a huge process, expensive process, for showing that drugs actually work. We can spend the rest of the time talking about homeopathy, but that's not the purpose of this talk. There's the absence of progress. There's no real change in the theory since 1810. And when you think of what science was like in 1810, a lot has changed. This personalization of the issues, homeopathy is equal to Samuel Hahnemann. It's also Jacques Benavista, who died, I think, 4 years ago, who was sort of the main proponent of homeopathy in France. And there's a lack of scientific method, no multiple controlled studies to show its effectiveness. And then my second insight, when I realized about 15 years ago that my interest in skepticism and working on experimental software engineering were the same thing, is software engineering research any better than pseudoscience? So this is this was sort of the message I gave at this talk about a month ago. It was this next slide. Let's identify pseudoscience. Is software engineering pseudoscience or real science? And each of these items on the right, I've seen in papers or I've spoken to people. Use of vague, exaggerated, or untestable claims. And I'll see comments made in various papers or various talks. My technique makes programming easier. Well, what does that mean? How much is easier? What does easier even mean? How much would be important? What's an important improvement? If it's something takes you 10 years to build and you can do it in 9 years, 11 months, and 28 days, is that an improvement? So we have vague, exaggerated, and untestable claims in many times. Over-reliance on confirmation rather than refutation. And typically you'll get a paper that says, here's this new system for doing something. And the paper basically says, I tried it and it works. Well, what does that mean? I'm building a new language, and I tried it to build a product. And the conclusion is, see, I built a product out of it. Doesn't mean it's any better. Doesn't mean you couldn't have done it some other way. But that's no proof that that new method or new language or new product really does any good. Lack of openness to testing by other experts. This is almost in the computer science world, which is not true in other scientific disciplines. It's almost institutional that you get a statement of the following: the paper is unpublished, unpublishable since someone already ran that study. In computer science, it's almost impossible to find a replication of a study, because the editors will say, well, we been there, done that. We don't have to read it again. Where if you read a medical journal, you'll often see, this is the 800th study that looks at this compound and what it does on this population. And this is one case where I think computer science does do a lot worse than other scientific disciplines. In fact, the study I'm going to talk about that I did, hope I remember it, to mention it, the first version of the paper was unpublished for that very reason. I'll mention that in about a few minutes. Personalization of issues. Techniques are often associated with the developer. You get the statement, I wrote it, I know what I'm doing. In fact, I've had that comment I've talked to, I remember twice in the past 10 years, I spoke to 2 leading researchers in the computer science world. And that's basically the answer I got when I said, because I'm very much into the experimentation model of software engineering. And I got both answers that says, I don't have to experiment. I'm a smart person. I know what I'm doing. And well, basically that's it. That's the only proof you need. That's proof by authority. And lack of scientific method, falsification is rarely attempted.